Today we are going to talk about Euler's number, e. E is an irrational number around 2.71828. It's like pi, but not as famous. Nobody goes around memorizing the first 1,000 digits of e. Euler defined e as an infinite series, 1 plus 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial, and so on. E can also be expressed as 1 plus 1 over n to the power of n as n approaches infinity. This is based on continuous compounding. To understand this, let's talk about interest. The first type of interest we're going to talk about is simple interest. So let's just say you borrow $1 from the bank, and after 1 year it's 100% interest. So at the end of 1 year, you would pay $2 to the bank. The next type of interest is compound interest, where you charge interest on the interest. The first type of compound we'll talk about is a bi-yearly compound, where the interest compounds twice a year. So if you're charged 100% interest per year and compounded twice a year, that means you pay 50% interest for the first 6 months, so you'll owe $1.50. If you pay 50% interest for the next 6 months, you'll owe $2.25 after 1 year. This can also be written as 1 plus 1/2 to the power of 2. Next up is a quarterly compound, where the interest is compounded 4 times a year. So, after 3 months, you will owe $1.25, and then, after another 3 months, you will owe $1.56, and then you will owe $1.95, and then you will owe $2.44, which can be written as 1 plus 1/4 to the power of 4. Now, let's try a monthly compound. Now that we figured out the formula, all we have to do is 1 plus 1/12 to the power of 12, which is approximately 2.61. What if we did a daily compound? That's what credit card companies do. If you plug it into the formula, you only make $2.714. That's not much of an increase. Now, let's compound every single milli, micro, nano, picosecond. And if we compound often enough, we can also call it a continuous compound. Do you know how much we would owe if we compounded continuously? Well, the answer would be $E. So as n gets larger and larger, 1 plus 1 over n to the power of n gets closer and closer to e. E wouldn't be used so much in banking because interest is generally compounded either monthly or daily. Growth in nature, though, like cell growth and population growth, is continuously compounded. For instance, we don't see bacteria grow every Monday or the first day of the month. In addition, radioactive decay, with half-life, and drug metabolism is also continuous. Therefore, E is an amazingly important number when we want to examine continuous growth or decay.